Vamos tapar aqui a vista com alma.
Hello everyone. I'm honored to present our keynote speaker, Professor Axel Uhl. Hopefully I said it right. Professor Alex, who is a trusted advisor to C-level representatives on business and IT side, professor of at the Institute of Business Information Technology since 2016 with a large number of published papers, and he works in Novartis SAP Switzerland as head of Business Transformation Academy. And he's telling us a little bit about digital transformation, and I will ask you to add whatever other details you think useful for our audience. Thank you very much for being with us.
Thank you very much for this very kind introduction. Thank you very much for having me here. It's the second time I'm invited to this conference. The last time I was here in Portugal was about 4 years ago. And since then a lot of things have developed in terms of digital transformation. And today I would like to share with you, I would like to introduce digital transformation as a kind of terminology. I would like to talk today about changing needs in our society. I will explain the concept of Industry 4.0, the objectives and the status quo of Industry 4.0. Then I will introduce some new technologies contributing to Industry 4.0. Eventually I will continue to talk about the impact of technology to our work, and I will introduce some possible scenarios for the future of work. So the overall presentation will take about 30 minutes, and then we have enough time to have a discussion. You can ask any questions you want, and I'll hopefully be able to answer them. So I work at the Institute of Information Systems at the University of Applied Sciences in Zurich. And we are dealing with a practice-oriented application of information technology. Enterprises can work together with us in various ways. It begins with the fact that interested companies can inform themselves by trainings or individual briefings. That's on the left side here. Subsequently, we support companies in developing initial ideas for the implementation of digitization. In doing so, we conduct market and competition analysis, DigiCheck, to determine the digital maturity, or design thinking workshops with the aim of identifying digital use cases. That is the second part. In addition, companies can also carry out implementation projects with us. These are often so-called speedboat projects, which allow companies to gain initial experience. And last but not least, companies can submit an application for a research project with us to gain access to government grants. I present this overview because it nicely introduces the possibilities that companies have to work together with us as an institute for information systems. And because we are not doing fundamental research, we are more in the practice-oriented research, it is important to us to work together with companies. So most insights, most experiences we don't get through typical research, we gain it through project work with our partners. So, when we talk about digital transformation, what does that mean? And the definition you can find on Wikipedia is digital transformation is a change associated with the application of digital technology in all aspects of human society. And we hear very often, if we do not change due to this digital transformation, then the game is over for companies. They have to change. And if they don't change, they are either Kia or no Kia. One slide missing. Hey, where's the slide? There's one slide missing. I don't know where it disappeared somehow. Okay. Good. Then I have to explain one slide. But when we talk about digital transformation, then we call it is one of the so-called megatrends. And there are in total 5 megatrends. In addition to climate change, urbanization, demographic change, and globalization, digital transformation is one of the so-called 5 megatrends. Megatrends are long-term, they are not finished after only a few years, but they can influence over decades. A megatrend influences our social world view, it influences our values and our thinking. A megatrend can fundamentally influence the supply and demand of goods or services. But it's not only technology that is changing when we talk about digital transformation. Yeah? It's also about the humans that are changing. We have an increasing world population. We have about 7 billion people today, and we estimate about 10 million people in 2050. We have an aging of the population all over the world. And in the Western countries, the population is declining. We are confronted with growing migration flows. But we are self-determined, we have a self-determined life into high age. And even for the elderly people, we have usually a good physical and mental fitness. And we can see a female shift in many countries. The women are on the rise. And we have a new generation, the Generation Y, with new expectations for flexible and self-determined life and work. And this creates a diverse, multinational, multicultural, and multi-religional society. What does it mean for the economy and for the customers? Today the customers have the choice between just too many offerings. They are like this rabbit who can choose between thousands of carrots. Charles Duell, chief of the American Patent Office, 1899, said that everything that can be invented has already been invented. The opposite is true. The constantly changing society is the basis for new needs, new products, and new services. We are ourselves new customers, and we have new customers. The new customers today are smart with Google wisdom. They are unloyal. but very high demanding. But they are also open-minded humans with just new needs. The key question is, how can we satisfy those needs? The answer is that we have to personalize our products so that they can create unique value for the customers. And looking back into the history of mass production, we first created unique products made by craftsmen, but with low efficiency. Here, 1880. Beginning of the 19th century, the industrial production started. The efficiency increased, but the variety of products declined. However, the demand for new products at this time was so high that every product found a customer. This continued until the 70s. But after most people had a TV, a radio, a refrigerator, and a car, the market started to change. The supply became larger than the demand. To differentiate themselves, the organizations began to produce mass customized products. But that was soon not enough differentiation. To stay competitive, companies need nowadays to produce unique products produced with the efficiency and costs of mass production. We call that lot size 1. Here's an example of a company that produces customized shoes and sportswear. So Nike gives you as a customer the opportunity to create the design individually for your shoes. And you will get those shoes delivered with exactly your fully personalized design. The same is true for some of their sportswear. So that makes a big difference. This is not commodity anymore. This is personalized product offerings. I make now a little step and talk about the steps of industrialization. The development of industrialization shows 4 revolutionary steps. The first took place with the invention of the steam engine at the end of the 18th century. At the beginning of the 20th century, the invention of electricity triggered the second industrial revolution. The third industrial revolution originated from the invention of microelectronics at the beginning of the 1970s. The fourth industrial revolution is nowadays associated with cyber physical systems, the Internet of Things, 3D printing, cognitive computing, and some other technologies. It can also be seen on the graphics that the innovation potential and the added value have increased in every revolutionary step. So the term Industry 4.0 originated from the fourth industrial revolution. Meanwhile, this term is very popular and has also established itself internationally. This can also be seen from how often the term is Googled compared to similar terms, such as the American term industrial internet. But what is behind industry and the term Industry 4.0? First, it is interesting that until today there is no clear definition of the term. However, after lengthy discussions, one is now clear about the goals of Industry 4.0. I talked already about it. One of the key objectives is a lot size 1 for costs of mass production. A connectivity along the whole life cycle without media breaks. The vertical integration through interaction of product, resources, and material. A seamless horizontal integration through value chain networks. And the main principles of Industry 4.0 are autonomy, self-control, and real-time capabilities. the disruption potential of 4.0 for different industries. The disruption potential of Industry 4.0, particularly in the production, is high. If the industries are distinguished between high or low disruption potential and a long or short spurt or time to implementation, then the production is one of the industries with the highest disruption potential. But it will take time. This means it will take a relatively long time until the technological possibilities can be implemented. Why is it that it takes so long? Summarizing the current status of Industry 4.0, the following picture emerges as a general classification. The terminology as a German approach for digital industrialization is very well established. It is well known on board and senior management levels. But they also have very high expectations. You can see already many single solutions implemented. But the downside is there's a lack of standards and a slow alignment on necessary standards. To make you a bit more familiar with the topic of Industry 4.0, I would like to briefly introduce some of the contributing technologies. First, there are the robots. So far, the robots used in the production have been more or less unintelligent and heavy. They could perform exactly one or a few jobs using hard-coded programming. If these robots take over other jobs, they had to be reprogrammed. But the future belongs to the second generation robots, so-called multi-purpose robots, who can learn new tasks independently. These robots will be able to network with other robots and learn from each other. For this, I would like to briefly show you a short video.
Google's been making leaps and bounds with learning robots lately, and its latest project claws its way into the world of robot fingers. Using 14 different robots, each equipped with 2 deep neural networks, Google engineers built robot arms with one mission: learn to pick up objects in one bin and put them in another. The neural networks are what make the grabbing magic happen. One looks at a photo of the bin to try and predict whether the robot hand can grab the object. The other network evaluates how well the arm grabbed it, and then it can tell the first how to change up its strategy. The research team has robots pick up ordinary objects 800,000 times. Untrained, they fail to pick things up 34% of the time. Trained, that number dropped to 18%. I'm taking one of these next time I play the claw game. For Newsfeed Social, I'm Molly Real.
So, let me just explain a little bit better what happened here. So there were a couple of robot arms who had to pick objects out of a box. They were not trained. So these robot arms didn't know how to pick the object. It's quite difficult for a robot arm to pick an object that the robot arm doesn't know how to pick it. But there was not only one of them, there were 15 of those robot arms. And they all had the same task. And they all tried to pick different objects out of the box. And sooner or later they learned how to pick an object. They failed a couple of times, and then suddenly one of those robot arms learned to pick one of the objects. And this robot arm shared the information how to pick this object with the other robot arms. So the other robot arms could learn from the first one how to pick the object. But in the meantime, the other robot arms also tried to pick an object out of the box, maybe a different one, and they learned how to pick the different object. And they shared this information as well. And at the beginning of the experiment, it took very long until the first robot arm could really pick one of those objects. It took really long. And then suddenly, when they started learning from each other, they became faster and faster. Huh? And at the end of the exercise, they could just pick the objects with a very high speed. So that is very different to the robots we saw in the past. Because in the past, if you want to ask a robot to do something, you had to program it exactly, had to tell the robot exactly what he has to do. And if the robot wanted to do something else, or you wanted to do the robot to do something else, then you had to reprogram it. That is the first time those robots can start learning from each other in huge networks. And these are only 50, but they could learn from hundreds or thousands of those. Let me give you another example. Available as of today are so-called light-wide robots. This signals the beginning of a new area in industrial sensitive robotics and lays the foundation for innovative and sustainable production processes. For the first time, humans and robots can work together on highly sensitive tasks in close cooperation. Thanks to its joint torque sensors, the light-wide robot can detect contact immediately and reduces its level of force and speed instantly. So the light-wide robot can learn via simulation, indicate the desired position, and it will remember the coordinates of the pass point. The light-wide robot is able to detect contours. It establishes the correct installation position and mounts components quickly and with the utmost precision. It gives the human operator a third hand and takes care of unergonomic, monotonous tasks, reliable and independently. But there are still a lot of questions open. For example, how can we best integrate light-wide robots into the world of work? How safe are those light-wide robots really? And will the light-wide robot take over the job of some of the workers? Another interesting technology that is supporting Industry 4.0 are so-called digital assistance systems. And they are the primary interface to optimally integrate human agents into the assembly system during task execution. Features of modern digital assistance systems come far beyond a sheer representation of information. They provide situational support through process-aware assembly tools. Work instructions are automatically provided in accordance with physical work progress and without any manual interaction with the system. And why is that important? If you think about a self-determined process in the industry, a lot of things are changing immediately. If a worker is working in such an environment, he has to get information in real time about what is produced, what kind of material is necessary, what is dangerous in this process step, what does he has to take care of. And this kind of information is immediately and in real time pushed to his screen so that he can really support this autonomous production process. Another big topic is big data. It's also on everyone's lips as a term, and one speaks of the gold of the digital age. The biggest big data problem? Inaccurate data. According to a recent report from Experian Data Quality, 75% of businesses, for example, believe their customer contact information is incorrect. If you have got a database full of inaccurate data, you might as well have no data at all. Another problem of big data is that we can use them to analyze unstructured data. Huge amounts of unstructured data, and we try to figure out maybe some correlations between different facts. But sometimes these correlations are just very confusing. So there's a high correlation of 95%, for example, between the divorce rates in the US and the consumption of butter. So what does that mean? Should we all eat less butter now? No, we have to take care, and we have to analyze whether these correlations that are produced by big data do really make sense. Another problem for big data usage is cybercrime insecurity, for which most companies do not know the effective answer. Augmented reality is another technology supporting the vision of Industry 4.0. Augmented reality is a technology that layers computer-generated enhancements atop an existing reality in order to make it more meaningful through the ability to interact with it. Augmented reality is developed into apps and used on mobile devices to blend digital components into the real world in such a way that they enhance one another. It is used to display score overlays, for example on telecasted sport games, and pop out 3D emails, photos or text messages on mobile devices. Big topic is also the Internet of Things. The term IoT means that the computer in the digital world is further equipped and connected with intelligent objects or even artificial intelligence. IoT involves extending internet connectivity beyond standard devices such as desktops, laptops, smartphones and tablets to any range of non-internet enabled physical devices and everyday objects. Embedded with technology, these devices can communicate and interact over the internet, and they can be remotely monitored and controlled. IoT creates opportunities for more direct integration of the physical world into computer-based systems, resulting in efficiency improvements and economic benefits. It enables the communication between machines and machines, person to machine, and objects and machines. Core technologies to be used are RFID chips, sensor actuators, cloud technology, IPv6, and data analytics. The number of IoT devices increased 31% year over year to 8.4 billion in the year 2017. And it estimated that there will be 30 billion devices by 2020. But despite all the technological possibilities, the reality shows that many companies, particularly small media enterprises, are hard at using new technologies. Only a few today use the possibilities of exchanging, for example, data with suppliers, or using mobile technologies. The possibilities for cloud computing are also little used. And social media are used, but most only for marketing purposes and not for the optimization of internal processes. So there's a huge gap between the possibilities and the usage of the technologies. So there's a gap between knowing and doing. Particularly on the management, there's a difference also between the knowing, between the managers and the employees. So a lot of the managers already know about those possibilities, but the employees don't know. And we can also find that only few companies really have a strategy how to implement Industry 4.0. And without a strategy, the implementation will be very difficult. Studies show that the biggest obstacle to the implementation of digital transformation are organizational barriers. A lack of willingness to change of the executives and employees is considered the biggest problem. Industry 4.0 is seen as a threat to jobs and companies. And companies are facing a trade-off. Investing in the new technologies threatens massive conflicts with employees and their representatives. And therefore, many of really sometimes good ideas how to use digital transformation fail, because they are just not accepted on the organizational level. The concern is that humans as workers could become obsolete by the robots. Humans do not need to apply. In fact, the impact of Industry 4.0 or digital transformation on employment is still unclear. Various studies come to very different statements. According to a very popular study from Frey and Osborne, 47% of US jobs are in danger. Bowles concludes for Germany that 51% of German jobs are in danger. A study made by the ING DIBA sees that 80 million of German jobs will get lost. The ZHAW, however, concludes that only 9% of today's US jobs and only 12% of German jobs are in danger. The consulting firm Boston Consulting Group sees it far more positive and concludes that until 2025, about 350,000 new jobs net will be created in Germany. According to a study made by IAB, about 600,000 jobs will get lost in Germany until 2025. And the World Economic Forum comes to the conclusion that 5 million jobs worldwide will get lost due to Industry 4.0. So there's a lot of uncertainty about what the impact of digitization, Industry 4.0, the robots and so on will have on the unemployment or on the employment. At the same time, new technologies changed in society and people as well as in companies could enable smart ways of working. But we would have to take into account in which activities the machines are superior to humans and where humans are superior to machines. So that machines and humans could work hand in hand together. Specific technological capabilities are sensors, IT, cloud, connectivity, the analysis of big data, objectivity, impartiality, measurement of physical data, clear reactions, defined actions, execution of actions without fatigue, multitasking. In those areas, technology is better than humans. Therefore, we need to design our workplace in a way to use the technical capabilities in the best way possible. But there are also some areas where the humans are better than the machines. Specific human capabilities are emotions, sensing, feelings, experience, behavioral memory, solving and assessment skills, combining ability, fantasy, flexibility, fast adaptation to environmental changes, intention and willpower, and communication skills. Technology can support those skills, but can't replace it. We therefore need to design our workplaces in a way to further strengthen those skills. Our conclusion therefore is, Industry 4.0 doesn't mean technology determinism. We clearly see the following three scenarios. The automation scenario, in which controlling and steering tasks are taken over by technology and workers are steered by cyber-physical systems and take over execution work. The second one is the maintenance scenario, in which controlling and steering tasks are cooperative and interactive and executed by connected objects, technologies, and humans together. And the skilled worker scenario, in which cyber-physical systems are a tool and support decision-making. However, the dominating role of the skilled employees stay preserved. We can see a bright future for the labor organization based on Industry 4.0. with healthy workplaces, age compliant, physical assistance through ability amplifier, connected working through multimodal machine-human interaction, innovative learning through mobile, personalized, situation adaptive, production control, decentralized, flexible capacities, complete production transparency, planning and maintenance assistance, location-based and context adaptive. Despite all the challenges, the question remains, how should organizations take Industry 4.0 forward? Here are some brief recommendations. Identify opportunities. Digitization enables new business models, new services, new products, and new business processes. Act instead of react. Don't wait until your competitors will act. And by the way, the most dangerous competitors come from the digital industry. Did you know, for example, that Apple sells more of its iWatch, than the entire Swiss watch industry altogether? The focus must lie on the value add created and not on technologies. Value add can only be improved if existing can be improved, replaced, or some new is created. And leverage strong partners to jumpstart your digital business. Thank you for your attention, and I'm open for any questions now.
Who wants to start?
In your slides you mentioned the loss of jobs, these kind of things, but have you considered the other way around? The opportunities that can be created because of Industry 4, the possibilities that can emerge from it?
Yes, as I said, there is no clear picture about the impact of digitization or Industry 4.0 on employment. I think that in some areas jobs will certainly get lost. If you look at self-driving cars, I think a lot of drivers of taxis, of trucks and so on, these jobs are over. Yeah? Or the person sitting in a retail shop at the cash machine, this is over. Yeah? Because people will pay on their own self-cashier. In the past there was there were 6 cash machines, and today there's one person overseeing some self-payment machines. Yeah? So these kind of jobs are definitely over. How many new jobs will be created over the next years in IT, we don't know. From my experience, it just everything takes much longer than expected. So if the technologies are maybe there, they were ready to use, but the organizations are not ready to use them. They are not mature enough. Sometimes the organizations are still have problems to implement and use their basic IT systems like ERP systems or CRM systems, and without having the foundation, you don't have to think about advanced technologies. So this is why it takes so much longer. How many additional jobs will be created, I can't say. I don't know. But it is certain, it's very sure that we will lose a lot of jobs in some areas.
What about also the softer skills that can be trained to the workers who lose their jobs? For example, a company can not just fire people, they can reroute them to other segments inside the company.
Yeah, the question is how fast you can train those people in areas where the human work is still needed. And if you have a low-skilled worker who then should, I don't know, train a robot or program a robot or doing something like that, I think that just takes too long until he is able to do this. So I don't know what happens to those people. I don't know.
Yeah.
Thank you, Professor, for your explanation. It was very interesting. I think this is I'd like to ask you, what is your opinion on any thoughts about the new Internet of Value? I mean, the one that comes with the blockchain technology. I don't know if you are familiar with this. The blockchain technology.
Okay, yeah.
Yes, that allows the not only the share of value of use, as we have until now, but also the transaction of value of exchange, with a lot of business implications and marketing implications. Any thoughts about it?
Although I personally have no final opinion on the usage of blockchain. It originated from cyber currencies, Bitcoin, and for selling and trading Bitcoins, it was a perfect solution, because it was anonymously, it was safe, because it was decentralized in decentralized systems, so you couldn't change that. And everything which was needed to make digital money successful was that there must be trust in it. That it's just digital money. It is created by nothing. So the process behind needs to be very trustfully, and that was the reason why it was a perfect solution for digital money. And there was a high motivation for the ones who provide the infrastructure, the servers and so on, because they were paid in those bitcoins. So there was the miners really had an incentive to provide the infrastructure for the blockchain technology. So if this was the origin and the core value was that it is decentralized and that it is trustfully and that you cannot manipulate it, then you need to look for other business scenarios which have the same kind of need, like it was with the digital money. And to be honest, I can't find too many of those scenarios where you have a very similar need.
Of trust?
Sorry?
The need of trust?
Trust, yeah.
Yes, health, for instance.
Yeah, but why shouldn't you store the data not in a centralized system?
Because if we do that, we cannot share it. Because there are privacy concerns, and you have to hospitals cannot share our personal data, for instance. Another area.
But you wouldn't solve this with blockchain.
With the blockchain, everything is transparent. Everything is you can share the part that you want to share, and not share the part that you don't want to share.
But the same would be true with a centralized system.
But in a centralized system, you should trust that centralized authority.
There must be one, like the government. There could be provide a centralized system, and then you have to define and agree with the terms what kind of information is shared between the different parties. So it was not about who's sharing this information with Bitcoin. It was anonymously. That was the reason why it was.
Sorry to disagree with you, because it's not anonymous. In fact, Bitcoin is very easy to find who has Bitcoin. The one that have Bitcoins is very easy. Very easy to find. Much more easy than dollars or euros. It's easy to find the owner.
Okay.
Yeah. Anyway, I just think that the Internet of Value should be present in this 4.0 terminology. I think if you think about 4.0, you should include the Internet of Value. Because machines, you talked about the Internet of Things, very important, but with the blockchain, machines can talk each other, one to another, and trust one to another. This is very important in terms of business, because you can have smart contracts, and you can have a lot of self-assembled business. You can have decentralized apps. You can have decentralized ways of doing business without that central authority you referred.
May I ask that you exchange?
Oh, yeah, of course. I'm sorry. Of course. So, anyway, thank you very much.
Yeah, you're welcome.
Axel, you presented 3 scenarios. First of all, I thought those alternative scenarios, but then, okay, these are 3 scenarios that can coexist. I guess
Yes. They will coexist, yeah.
they will coexist in different sectors. Will follow different. Will settle in different scenarios. That's what you have in mind, right?
Yes.
Mm-hmm.
Yeah, so it depends on the task, which of the scenarios is used. So as I said, the automation scenario means here the control and steering tasks are driven by the technology, because the technology can do it better than any person. But if you have tasks where you need fantasy or combination ability or experience or something like that, or creativity, then maybe the skilled worker scenario is better. So it depends on the task which you would like to perform. And you use the technology if the technology can do it in a better way, or you use more of the human skills if the human worker can do it in a better way.
Okay, and well, following these developments and when we enthusiastically act instead of reacting and adopting this, I start wondering what is going to happen to our species, to the sapiens, and what will be the next. I don't know how far away that is. I suppose it's not for my lifetime, but I think we start seeing that some dramatic change will appear. So we as species evolved from needs that are not anymore. So what shaped us is not anymore the kind of environment we live in. So any thoughts on how this will this evolution will shape what humans will be like in more or less far away future?
Yeah, it's always difficult to make a prognosis, particularly if it goes into the future.
Right. Yeah, I completely agree with that.
So I don't want to say that I know how this could look like, but first of all, from what we thought in the past, how fast things go, it always takes much longer than we expect things to happen. If you look at where we stand in terms of artificial intelligence today, there are a lot of things are already start to be possible, but reality is we are far away from something that is more intelligent than a human being. We try to, artificial intelligence means we want to develop something which is similar intelligent than a human being. And there are certain things where the technology is maybe better, analyzing the data. But if you compare that with the intellectual possibilities of the human brain, we are far away from that. And it will take very long until something is developed that is really more intelligent than human beings. So I don't know if it is ever possible that machines will completely take over the world. I don't know. But what we can see is also that we use the technology to optimize maybe human beings. It could be that you have a video camera on your length in front of your eyes, and you just film everything that you see. And if you want to remember something that happened a couple of years ago, it's somewhere stored, and you just go back and look at it again and say, this is how it looked. Yeah? You don't have to keep it in your memory. It is externally saved. So things like that are possible. Or the US military works with kind of skeletons, so machines that give you extra power, so that you can run maybe 2 times or 3 times faster than a normal being, a normal human being. So it's a combination of technology and human being that increases the capacities and capabilities of humans. But nevertheless, this is still some kind of future scenario. Let's assume that we replace a lot of the jobs today by robots. I think these could also give us the freedom for a very bright future. Because whoever told us that we have to work 8 to 9 hours a day? So let's assume that we lose 30%, 40% of the jobs. What could we do? We could just share the available work between the people, and instead of working 8 hours a day, we could work only 4 hours a day. And with the other time, you could do something which is maybe more meaningful for the society. You could work, you could contribute to the work in your society, in your city, in your hometown. You could spend more time with your children or your elderly parents and so on. You could do something which really makes sense, and you don't have to spend 8 hours a day in your job, even if you like it. But there are maybe better things to do. And many people don't like their jobs. They're just forced to do it. So the question is then, if these jobs and if this work is done by robots and the value is created, you can then distribute it throughout the society. And we could reduce the differences between poor and rich people all over the world, which is the driving force for any kind of conflict. So we could make something really useful out of it.
May I ask, how do you see the digital transformation of higher education?
Oh, that's a very very interesting question, because I think many of if I think about how we still educate our students, then a lot of things are still done in the classroom. And the people have to come to the university, they have to search for a parking space, and they have to find a seat in the lecture rooms and so on. And then they spend 1.5 hours listening to somebody who is just sharing his knowledge. And independent of who shares his knowledge, it is maybe not the best lecture in the world. So I could imagine that some organizations really create world-class knowledge and provide this as online courses for the students. Why do we have to develop, all our professors have to develop another ERP course or another CRM course or another Java programming course or another controlling and finance course? This is commodity information that is available 100,000 times in the world. And every professor again and again creates his unique course because he thinks this is better than any other course in the world. And it's not. This is commodity. So why do we spend time doing this? Why don't we just offer this as a standard all over the world? Today, we see the translation courses, the translation engines are becoming so powerful that you can create it in one language and you can just translate it in a very, very short period of time. The translation will be available in real time. So, and then we can think about what could we do which is more useful than giving a lecture in a classroom. Maybe because it's coaching of projects, it's coaching of individuals, it's interaction, it's sharing of experience, something that is individual. It's enabling creativity and improving communication skills and things like that. Where we as a human and as a professor are maybe better than the machines. It's the same is true for us as it is true for any other job.
Thank you for your presentation. Will there be a way to compensate the job losses by giving the affected people in the humanities? Because the corporations will be saving money anyway, because robots don't require payment, and they just consume a bit of electricity. And also have an initial investment cost, but they're still way cheaper than a human worker. So do you think that most enterprises could afford to indemnize those people and let them have enough money to live the rest of their lives, while the new generation gets educated on the new technologies, so they can get a job on another areas?
First of all, I think if an organization invests in robots or automation or computer programs or whatever, then it has an economical reason to do it. Mostly because it is more efficient or it is more effective. Meaning, if they are right, then they invest the money and they become more productive, more efficient, more effective. So they will be successful on the market, creating a lot of money. And from this money they create, they just have to pay taxes to the countries. And then the government can take this money and distribute it between or within the society. Can give it to those people who have maybe less jobs. And on top of that, we would maybe share the amount of work, as I said, in a different way. Not some people working 16 hours and others have no job, so we would share that and bring everybody on the same kind of level. It would also mean that we may have to reduce the level of comfort and slightly within a society. Why does everybody need a big house or 2 or 3 cars and so on? We may have to go to a level which is good for everybody, but it is not such a luxury life. And if we would do this, it would also be better for our environment, and also for our life, because I think we just overconsume in many cases, and we don't improve our lives by having another flat and a bigger car and a newer mobile phone or whatever. It doesn't really make us happier, but it makes us more dependent on our jobs and the income, and so a lot of, we call it extrinsic motivators instead of intrinsic motivators. So we have to live more, probably we have to live, and we will get the opportunity to live more with our real intrinsic needs rather than these extrinsic needs which are driven by advertisement and other things.
Do you think robots should pay taxes?
I'm not saying that the robots should pay taxes, but the companies should pay taxes. They make the money, they use the robots, so they can pay taxes.
One last question, please, because we are...
I would pick up on that, not about robots paying taxes, but because of the industry 4.0 as a whole. So if we are digitizing processes and we have automation not only physical but also digital and virtual, how can we think about taxes at a global scale in this new model of the economy? Because you are saying that probably the employment will reduce in our country, but people will have more time. But the question is, if we have a digital global economy that is going to Industry 4.0, and how are we going to build a tax system that works globally and can redistribute?
Yeah, that will be a big political challenge, I think. I'm not sure whether it is really feasible for now, because there will still be some countries who are looking more on their own interest and rather on the overall interest. And that is, as I said, still the reason for many conflicts. So we need to think more in global terms and fairness across the world, then we don't have all these migration flows and all the other problems. There's enough food on the world, there's enough water on the world, so if we just distribute it in a better way, we could get rid of a lot of problems.
Okay, thank you very much. I invite everyone to the lunch and exchange with Professor Axel ideas and ask other questions that could not fit in time here. So thank you very much.
Thank you very much for your time.
O almoço está a ser servido lá embaixo. No final do corredor, descem as escadas, do lado direito e o bar, saem para fora. Está bem?